So we're going to look at another speed velocity problem. So we're supposing an arrow is shot upward on the moon, so gravity is a little bit different, at 65 meters per second, and its height in meters after t seconds is this equation right here. And what we want to do is find velocity, which is a slope. So let's graph that, 65 minus 0.83. Let's play with Desmos. So I'm going to call this, let's see, h of x equals 65, our initial speed, and then gravity 0.83 x squared. Make sure I copied that right. Yep. All right, and then let's just rescale to see this. Let's start by zooming out. And let's see, we're most concerned about 6 seconds in. So let's see where we're at. If we ask the computer what is h of 6, we get 360. So we're going to get that monkey wrench there and let y go past that. Maybe we'll go up to 500. Let's go higher. Let's see what 1,000 looks like. Yeah, so the peak is somewhere up there. Let's find that peak. I'm just curious. Oop, not 5,000. I'm going to go to 2,000. There we go. And we are concerned about the point 6, comma h of 6. Right there. So we want to know about what is the slope at that point. So this graph right here isn't the trajectory of the arrow. It's only the height of the arrow at so many seconds in. So 6 seconds in, it's at 360 meters. And then somewhere around 40 seconds in, it's up here at around a little 1,300 meters high. But the horizontal axis is not distance from the person shooting it. This is just height versus time. And the slope at this point right here, slope is rise over run. The rise is meters, the run is seconds. So the slope is meters per second, which is the velocity of this thing. Let's get a screenshot of that just for fun. All right, so, and it's saying, okay, let's just look between 6 and 7, and then 6 and 6.5, 6 and 6.1, 6 and 6.01, 6 and 6.001. And so the closer these 2 points to get together, the closer we are to finding the slope, the speed at that instant in time right there. Okay, and that kind of looks like a straight line there anyway, because we're zoomed in on the curve there. So we're trying to find the slope of that green line by picking a couple of points nearby. Now those points are on the curve, not the line. So all of those are just approximations, but hopefully we'll see a pattern here to those numbers. So I'm going to write down a little bit here. So remember, we're trying to find slope between those points. Oops. And our slope, oops, is rise over run. And that's the whole y2 minus y1 over x2 minus x1. And so here they're giving me the x1 there, and that one's the x2 right there. So they're giving me those two numbers. And my y is really the h here. So another way to think about this, instead of y2, that's really h, plug in x2. And the y1 is really h, plug in x1. And that's what I'm going to use my calculator to do. So I'm going to enter this into my calculator right there. And I often find it helpful when I'm working with functions in a lot of different classes to actually name the function like I did right there. So to find the slope between 6 and 7, I'm going to hit the division key first. And again, that's the slash on the keyboard. If you're using Desmos, you can bring up the keypad and use the keys here. And then in my numerator is going to be h of 7 for the first slope, close parentheses, minus h of 6. So that's my rise. And my denominator is just going to be 7 minus 6. And then it calculates a slope for me of 54.21. And then I just want to keep repeating that slope idea. So I'm just going to do another division. And the next one they gave me was 6.5. So h of 6.5 minus h of 6 divided by 6.5 minus 6, which you could do in your head and just call it 0.5. I'm going to write it out here. And here I can see the slope is 54.625. And then I'm just going to keep repeating that. So I'm going to do that one more time, and then I'm just going to do a little shortcut on that. So division, h of, I think the next one was 6.1, minus h of 6 divided by 6.1 minus 6. So 54.2-ish, 54.6-ish, 54.957, right? So I've done the first three here, and then it goes 0.01, 0.001, and we're hoping to see a pattern ultimately is what Calc 1 is about. This is just kind of getting warmed up for the other kinds of problems we're going to do. So rather than retype this, I'm just going to replace that 6.1 there with a 6.01 and do that in the denominator too. All right, 55.03. If I put another 0 in there, 59.03917. So let's go back here a second. So there's definitely some kind of pattern going on there. And if I keep getting closer to 6, then it should zoom in on what the actual value is. All right, so it looks to me that that the slope there might be 55.04 if I keep getting these points closer and closer together. And notice I'm leaving the 6 fixed. So this blue point down here I'm leaving fixed, and then I'm just taking another point and moving it closer and closer and closer to get the slope there. Now this problem didn't ask me to go that deep, but that is what Calculus 1 is all about. Trying to find a pattern as one point gets closer to another one to say, oh yeah, look at the slope is 55.4 at that instant, which is kind of a weird idea, but that's what we're going to work on. All right, so that's a nice tool there, GeoGebra function notation.